Lesson: Intrusion Detection Systems Augmented with AI. Intrusion detection systems augmented with artificial intelligence represent a significant advancement in network security. Traditional IDS rely heavily on predefined patterns and signatures to identify potential threats. However, with the increasing sophistication of cyber attacks, these systems often struggle to keep pace. AI brings a new dimension to intrusion detection by enabling systems to learn, adapt, and respond to new threats in real time, enhancing the overall security posture of organizations. AI-augmented IDS leverage machine learning algorithms to detect anomalies and potential threats. These systems analyze vast amounts of network data to identify unusual patterns that may indicate a security breach. One practical tool for implementing AI in IDS is the open-source machine learning library TensorFlow, which can be used to develop models that identify deviations from normal behavior in network traffic. For instance, by training a neural network with TensorFlow on labeled datasets of normal and malicious traffic, an IDS can learn to distinguish between legitimate and suspicious activities, even when the latter does not match any known signature. Another effective strategy is the use of unsupervised learning techniques, which are particularly useful for identifying zero-day attacks. These attacks exploit vulnerabilities that have not yet been discovered or mitigated by security professionals. Unsupervised learning algorithms, such as clustering, can group similar data points and identify outliers that deviate from the norm. A practical example is the use of the k-means clustering algorithm to classify network traffic into normal and suspicious categories. By continuously updating the clustering model with new data, an IDS can adapt to evolving network behaviors and detect previously unknown threats. Reinforcement learning, another subset of AI, can also enhance IDS capabilities. This approach involves training an agent to make a sequence of decisions that maximize a reward function, such as minimizing false positives and false negatives in threat detection. An IDS using reinforcement learning can dynamically adjust its detection thresholds based on feedback from its environment, improving its accuracy over time. An example of this is using a reinforcement learning framework like OpenAI Gym to simulate network environments and train IDS models to optimally balance between detection sensitivity and performance. The integration of AI into IDS also brings about improvements in threat intelligence sharing and response automation. AI can analyze threat data from multiple sources and correlate it to provide actionable insights. A case study involving the use of IBM's Watson for cybersecurity illustrates this capability. Watson's AI algorithms can process and analyze structured and unstructured data from various sources, such as threat reports and blogs, to provide comprehensive threat intelligence. This enables security teams to prioritize alerts and respond to incidents more effectively, reducing the mean time to detection and response. One real-world example highlighting the effectiveness of AI-augmented IDS is the implementation by a financial institution dealing with high volumes of sensitive transactions. The organization employed a combination of deep learning models and anomaly detection algorithms to secure its network. By analyzing transaction patterns, the system could detect fraudulent activities that traditional signature-based IDS missed. As a result, the institution reported a 30% reduction in undetected threats and a 40% decrease in false positive rates, significantly enhancing its security measures. Despite these advancements, challenges remain in implementing AI-augmented IDS. One significant issue is the quality and availability of training data. Machine learning models require large volumes of labeled data to perform effectively, but acquiring such data can be difficult due to privacy concerns and the dynamic nature of cyber threats. To overcome this, organizations can use synthetic data generation techniques or collaborate with other entities to share anonymized datasets for model training. Moreover, the complexity of AI models can sometimes lead to a lack of interpretability, making it difficult for security analysts to understand and trust the decisions made by the IDS. To address this, explainable AI techniques are being developed to provide insights into model predictions. For instance, the LIME framework can be used to generate human-readable explanations for the decisions made by complex machine learning models, enhancing transparency and trust. In conclusion, AI-augmented IDS present a powerful tool for enhancing network security. By leveraging machine learning and other AI techniques, these systems can detect and respond to threats with greater accuracy and speed than traditional methods. Practical tools such as TensorFlow, OpenAI Gym, and Watson for cybersecurity can be employed to develop and implement AI-augmented IDS, providing organizations with actionable insights and improved threat detection capabilities. As the cybersecurity landscape continues to evolve, the integration of AI into IDS will be crucial in maintaining robust defense mechanisms against increasingly sophisticated cyber threats.